All right, we are going to begin our final unit of this year, this course. Unit 11 is titled Solving Quadratic Equations, and we're going to look at solving quadratic equations 4 different ways. There's actually a few more than this, but we're just going to take a look at these 4. So we're going to solve quadratic equations, like the one listed below, by graphing. So we're going to use the graphing features and graphing technology today. We're also going to take a look at using square roots as a way of solving certain quadratic equations. We wouldn't be able to do that on this one. We're going to solve by factoring. Sometimes when you have a quadratic, like a quadratic polynomial, you're able to factor it. And if you can factor the quadratic, then you can usually solve that way. So we'll look at that. And then also there's this thing called the quadratic formula. It's actually a pretty complex formula, but it will solve any quadratic equation that there is. It's pretty cool. So we can always solve by graphing if we have the technology. We can always use the quadratic formula as a way of solving any quadratic equation. And then the solve using square roots and factoring methods are really, they only work at certain times. So we'll talk about that more in future lessons. So let's talk about solving quadratic equations by graphing today. Let's start with just a few vocabulary terms for understanding. First, we have, what is a solution? So when we say that we're solving a quadratic equation, what does that mean? Okay, it means that we're looking for a value for x, or whatever the variable is, that's going to make the output of the equation equal 0. Okay, so in other words, if x squared equals 9, what number would complete that statement? Okay, what possible values for x are there? Well, most of you probably right away looked at that and said, well, I know that 3 times 3 is 9, so x can equal 3, right? Okay, well, yeah, I guess 3 squared is 9, so that would work. Since 3 squared equals 9, x could equal 3, but are there any other possible solutions to this equation? Doesn't negative 3 times negative 3 also equal 9? So negative 3 squared is 9. That means that x could also equal negative 3. So there's actually 2 solutions to this quadratic equation. And most of the time, we will get 2 solutions to a quadratic equation. There very rarely is there 1 or no solutions, but that is possible too. And we'll talk about that again in the future. So where is the solution on the graph of a quadratic function? So if we're going to solve by graphing, it's important to note where we find these answers. Where is it? Last unit, we looked at different features of quadratics. We focused a lot on the vertex, the y-intercept, whether the parabola opened up or opened down, if there's a minimum, a maximum, and so on. One of the things that we mentioned was x-intercepts. We didn't talk about them a lot, but x-intercepts are really the clues that give us the solution, because that's where the solution occurs, at the x-intercept of the parabola. So when we solve by graphing today, we're really focusing on those x-intercepts. So if this is my parabola, and this is my x-axis, where does my parabola cross the x-axis? Okay, it's usually going to happen in 2 places, right? It's going to go down and back up through the x-axis twice. So here's a better example with an actual grid behind it. And it says, in this graph, the parabola crosses the x-axis twice. Okay, once on the left side, once on the right side. And we can see that our origin is on the left here. And then we have, 5 spaces and then the number 5. So it looks like we have 1, 2, 3, 4, 5. Everything's counting by ones on our x-axis. So the solutions occur when x equals 1 and when x equals 5. Okay, in other words, the x-intercepts are at 1, 0 and 5, 0, because that's the coordinates of each of those 2 points. Okay, so the x-intercepts are the point on the graph. The values that are the solutions to the equation, though, are x equals 1 and x equals 5. But you see the relationship between the x-intercepts and the solutions? So in that previous graph, we were actually showing the parabola for y equals x minus 3 quantity squared minus 4. So what we're going to do here is we're just going to show that x equals 1 is a solution and that x equals 5 is a solution. Now, if x equals 1 is a solution, that means that 1 comma 0 will, when we plug this in, make the equation true. So we have y equals x minus 3 quantity squared minus 4. And if I want to check 1 comma 0, that means that my x value is 1 and my y value is 0. So I'm just replacing my x and my y here. And I'm just going to check, does the right side actually have an overall value of 0? So 1 minus 3 is negative 2. I do that in the parentheses first. Then I apply the exponent. So negative 2 multiplied by negative 2 is positive 4. And 4 minus 4 is 0. So it is true, which tells me that 1 comma 0 was actually one of our solutions. Now let's check 5 comma 0 and see if that will solve our equation. Y equals x minus 3 squared minus 4. So I'm going to substitute my values for x and y. So my x value is 5 from that ordered pair. The y value is 0. And we're just going to show that the right side has the same value of the left side, making it true. So in the parentheses, 5 minus 3 is 2. 2 to the second power, well, that's just 2 times itself. So 2 times 2 is 4. And 4 minus 4 is 0. It checks out there as well, which again tells me then that 5, x equals 5, is one of our solutions. It will make it a 0, as we call it, because it's going to make it equal to 0 on that side. So in this example, it says, what are the solutions? Let me zoom in a little. For the quadratic function. So here's my first one on the graph. I want to find, let's see, solutions, which we've identified will occur at the x-intercepts. One of our x-intercepts is at 2 comma 0. So one of my solutions is x equals 2. My other x-intercept, let's see, I have to count careful. It's kind of hard to tell, but it's to the left of the origin. So that's negative 1, negative 2. That looks like negative 3 right there. So I have an x-intercept at negative 3 comma 0. So I have a solution at x equals negative 3. So my two solutions are negative 3 and positive 2. So what do we have for a solution on this graph? Well, if I were able to zoom in even further, which unfortunately I can't, I would notice that my parabola comes down to the x-axis and it just barely touches it right at the bottom, right at that vertex, and then it swings and goes back upward. So on this one, it is crossing the x-axis, or at least touching the x-axis right at 2 comma 0. So my solution, my one and only solution, is actually just x equals 2. Now when this happens, because quadratic equations will always have two solutions, this single solution counts for like double. Okay, I don't double the 2, but it's a double root is what we call it. It's like a double solution when it occurs, or it only touches the x-axis at one point. Okay, so just to give you a little idea for how that works. Usually it crosses twice, but if the parabola comes down and touches it only at one point, it's considered a double root. Okay, it's like x equals 2 twice. Okay, x equals 2 and x equals 2. Now there is an example of, let me add one more in here, where you might have, here's your graph, and let's do a parabola like that. Okay, if this is my x-axis, how many times did the graph cross the x-axis? Yeah, it didn't. So in this case, we would say that there are no real solutions. We'll find out later that there are solutions, they're imaginary solutions, but there's no real solutions. Okay, we don't have any because we don't have any x-intercepts of the graph. So if that happens in any of your work today, no real solutions is your answer. So here we have an example of something like you'll see in your homework today. What are the solutions for the quadratic equation y equals x squared minus 6x minus 7? Now we don't see the picture of the graph, and it says solve by graphing in our topic for today. So for this, we're going to need to grab some graphing technology. So I'm going to open up my Desmos graphing calculator. Let me just quick memorize that equation. Y equals x squared minus 6x minus 7. So I'm going to go to my graphing calculator, Desmos.com, click graphing calculator, and I want to type that equation into the equation space. So y equals x squared minus 6x minus 7. I have to double check. Is that the right equation? Yes. Okay, we're good. So we can see the parabola. You can always zoom out if you want to see the whole thing. I want to go back to my regular zoom here. So if I click in the equation space, or if I would have clicked on the line, on the curve here, the parabola, I get these little gray dots that appear right on this x-axis. And you'll notice the x-axis is the one that's numbered. And if I were to click on those gray dots, they become little black dots, and then I can see the coordinates, even when I move my mouse away from that. Now, if I click somewhere else on the graph, those are going to go away. Okay, and I don't want that. So I'm going to click on my parabola again. I want to make those so they're visible. So my x-intercepts occur at -1, 0 and 7, 0. So I'm going to just record here that my x-intercepts are -1, 0 and 7, 0. So what are the solutions? My solutions then are x equals -1 and x equals +7. Those were my values within my x-intercepts. Okay, so the ordered pair isn't technically like the solution. The solution is the value for x that will make this thing equal 0. So -1, if we were to plug it in, do -1 squared minus 6 times -1 minus 7, that would make this equal 0. But also, if x equals 7, 7 squared minus 6 times 7 minus 7, that will also actually give you 0. So that's why there's two solutions. There's two different values for x that will make this equation equal 0. All right, that is it for today. Do the recommended homework, try that, check your answers, and then the quiz. Have a great rest of your day.